Let us discuss more examples on how to factor trinomial wherein a is equal to 1. So in our first example, our c is equal to positive 45. So the signs of the factors of 45 should be the same sign as our b, which is positive. So the factors of 45 that we have to consider should be both positive. Let's try 1 and 45. 1 times 45 is 45, but when you add, you'll get 46. So we need to get another combination. Let's try 5 times 9, it's 45, and the sum is equal to 14. So this will be the combination that we need. Answer will be x plus 5, x plus 9. Alright, example number 2. C is positive, so the signs of the factors of 20 that we have to consider should be the same sign as our middle term, negative. So we need to consider negative factors of 20. So we can try negative 1 and negative 20, but the sum here is equal to negative 21. So negative 1 and negative 20 will not work. Let's try negative 2 and negative 10. Negative 2 times negative 10 is 20, but the sum is negative 12. So negative 2 and negative 10 did not work. Let's find another factor. Let's say 4. Negative 4 and negative 5 is equal to 20. The product is equal to 20. The sum is negative 9. So negative 4 and negative 5 did not work. Do we have any other possible factors of 20? So in this case, it seems like we already have all the combination. So there's no way for us to, after trying all these combinations, there's no way for us to get a sum of negative 5. Therefore, number 2 is a prime polynomial. Alright, example number 3. Okay, my C here is positive, so the signs of the factors of 90 should be the same thing as negative. Since C is positive, the sign of the factors of 90 that we have to consider should be the same sign as our middle term. So it should be both negative. Let's try negative 2 and negative 45. So negative 2 times negative 45 is 90. But if you add these two, you are going to get negative 47. Now we need negative 19. Let's find another. You can have negative 9 and negative 10. The product is 90. The sum is negative 19. So this is the combination that we need. X minus 9, x minus 10. For the example, our C is negative. It means that the factors will be 1 positive and 1 negative. Our middle term is negative, so the factor that has a higher absolute value should be negative. So for example, if we will try 5 and 3, for example, 5 has a higher absolute value, so 5 is the one that should be negative. Then 3 here. Negative 5 times 3 is negative 15. And if you add these two together, you're going to get negative 2. So our answer will be n plus 3, n minus 5. Let's try example number 5. C is negative, so the factors will be 1 positive and 1 negative. So 1 positive and 1 negative. This one is positive, so the factor that has a higher absolute value should be positive. So if you try 7 and 1, 7 should be positive and 1 will be negative. So 7 times negative 1 is negative 7. If you add 7 and negative 1, you are going to get a positive 6. Alright, so this will be our answer, n plus 7, n minus 1. Example number 6, c is negative. So again, the factors will be 1 positive and 1 negative. So 1 positive, 1 negative. Now, since our b is negative, the factor that has a higher absolute value will be negative. So if you will try, let's say, 2 and 14, 14 will be the one that is negative and 2 is positive. When you add 2 and negative 14, you are going to get a negative 12. We need a negative 2. So 2 and negative 14 did not work. Let's try 8 and 6. One should be negative. The one that has the higher absolute value should be negative. So negative 8 and then 6. So negative 8 times 6 is 48. If you add these two numbers, you are going to get a negative 2. So this will be the correct combination. V minus 8, V plus 6. Alright, let's skip number 7. Let's do number 8. For number 8, it seems like we have a GCF. So 2 times the quantity k squared minus 5k minus 6. Okay, so inside the parentheses, we have a trinomial, and c is negative. It means that the factors that we have to consider should be 1 positive and 1 negative. Our b is negative, so the factor of 6 that has a higher absolute value should be negative. So if you try 3 and 2, for example, so 3 has a higher absolute value, so 3 is negative, 2 is positive. 2 times negative 3 is negative 6. When you sum these two, you're going to get a negative 1. I need a negative 5, so negative 3 and 2 did not work. Let's try 6 and 1. 6 will be negative. So negative 6 times 1 is negative 6. The sum is equal to negative 5. So this will be the combination that we need. So you will have k minus 6, k plus 1. Alright, example number 9. C is positive. Since C is positive, the factors or the signs of the factors that we have to consider should be the same sign as our middle term. Now, since this one is positive, the signs of the factors of 35y squared should be both positive. Alright, let's try 5y and 7y. So 5y times 7y is 35y squared, and the sum is equal to 12y. So this is the combination that we need. We'll have x plus 5y and then x plus 7y. Now if you want to check your answer, and I suggest that you check your answer every time you have your factors. So first, x times x, and then outer x times 7y, which is 7xy, inner 5y times x, will get 5xy, and then 5y times 7y will give us 35y squared. These two are like terms. We'll get x squared plus 12xy plus 35y squared, which problem that we just solved. It means that our answer is correct. Let's do number 10. Number 10, my C is positive, so the sign of the factors of 20y squared should be the same sign as the middle term. Now our middle term is negative, so we should have two negative factors here. Let's try -1 and -20y. So negative y times negative 20y will give us 20y squared. If you add, you are going to get negative 21y. So I need a negative 9y. So what if we try negative 5y and then negative 4y? The product is equal to 20y squared. The sum is equal to negative 9y, which gave us the middle term. So our answer will be x minus 5y, x minus 4y. And again, don't forget to check your answer using the FOIL method.